Hello, my dear students. Uh, in our present class, we are going to discuss some very important topics on organic chemistry. And the topic is hyperconjugation. Hyper. I think the board is visible. Conjugation. Hyperconjugation. The topic of today's class is hyperconjugations. Okay. I think the board is quite visible now. So before starting this class, mm, I'd like to say that you are not asked, you will not asked to write down the definition of hyperconjugations in your entrance exam. Rather, you are actually you will be provided some typical questions, and rather than say explanations which are basically based on the hyperconjugation, which can be explained. Actually, such questions can be explained based on hyperconjugations. So to give the answer of such questions, first of all you should learn what is hyperconjugation. So what is hyperconjugation? Let's start with an example. Suppose this is an alkene, this is an alkene. So this is an alkene. What is the name of this alkene? This is 1 2 3. This is propene. Prop 1 in. This is propene. So in this alkene, uh, so 1 here, 1 and here 2. So in this alkene, total 3 hydrogen are attached to a pi bond. Okay, so in similarly, very uh, often it is remains as like this. So it will give the resonating structure. So it will give the resonating structure like this. It will give the resonating structure like this. So as we know that the number of resonating structure, more the number of resonating structure, more will be the stability. More the number of resonating structure, more will be the stability. So therefore, similarly, so what happened? I am just write down first, then I will explain what is happening here. So look, although there is no alternative pi bonds, in this alkene, rather such alkene show one, two, three resonating structures. Such alkene shows 1, 2, and 3 resonating structure, and each resonating structure, the bond between the carbon and hydrogen, the sigma bond between the carbon and hydrogen breaks, and each of the hydrogen atoms get a positive charge in each case. Okay, so actually, although the bonds between the carbon and hydrogens are broken, but the hydrogens are not goes far apart from this molecule. Okay, it actually resides near the molecule, so such kind of resonance is called no bond resonance. So hyperconjugation has an alternating name. This is called no bond resonance. No bond resonance. Why this is called no bond resonance? Because the bond between the carbon and hydrogen atoms will be broken. Okay, and that's why it is called no bond resonance. So there is a interaction, there is an interaction occurs between the pi bond, between the p orbital of second carbon atom and the sigma bond. So this is called sigma pi interaction. This is called sigma pi interaction. This is called sigma pi interaction. So how to calculate the number of, actually all these structures are resonance structures. So hyperconjugation is nothing but a way to give the resonance structure, and as we know, the number of resonance structure, more the number of resonance structure, more will be the stability. So if there is a chance to attain hyperconjugative structure, the molecules gain stability. Okay, so hyperconjugation hyperconjugation brings stability. Hyperconjugation brings stability through resonance. Hyperconjugation brings stability through resonance. This is resonance. Okay, so I am going to remove the writings. I am requesting my dear friends to please write down the notes. So basically I will give an example. So the main point is, actually the hyperconjugation, the point can be noted, the hyperconjugation is a sigma pi interaction, is a sigma pi conjugation, sigma pi conjugation or interaction, sigma pi conjugation. This can be called no bond resonance. I am summing up the all the concepts. This can be called no bond resonance. The number of the more the number of more the number of hyperconjugative structure, more will be the stability, more will be the stability. Number 4, more will be the stability. And number 4, the total number of hyperconjugation is equal to the number of alpha hydrogen atoms. So I am going to elaborate the fourth point. I am going to elaborate the fourth point here. The number of total number of hyperconjugation is equal to the number of alpha hydrogen atoms. Okay. So if you if you can understand the fourth point, you can easily explain all the questions regarding hyperconjugations. Okay, look, say our questions. Explain the stability order. Explain the stability order. CH3, C, CH2, A, B. This is CH3, C, CH3, CH2, number C. So we already have seen that the number of actually the alpha hydrogen atoms are taking part in hyperconjugation. So the number of the alpha hydrogen atoms in A in structure 1 in structure A, number of, this is the alpha hydrogen, this is the here the alpha hydrogen. So number of alpha carbon, this is the alpha carbon. So number of alpha hydrogen is 2. In B, this is the alpha carbon, so number of alpha hydrogen is 1. And C, it is the alpha carbon. Alpha carbon means the the first neighborhood carbon atom after carbon carbon double bond. So here the no carbon atom, only carbon atoms are present here. So this is the alpha carbon atom. So alpha hydrogen atoms, number of alpha hydrogen atoms is 3. So this is the number of alpha hydrogen atoms. So number of hyperconjugation, number of hyperconjugation in A is 2, because number of hyperconjugation structure is equal to the number of alpha hydrogen atoms. So this is the 2, and this is in case of B it is 1, in case of C it is 3. And we already know that as more the number of hyperconjugative structure, more will be the stability. So according to the number of hyperconjugation, the more stable of the structure is C, is the more stable. So then comes A, then comes B. This is the stability order. This is the stability order. Okay, my dear students. So today we will stop here. I hope you will learn something. And if you do have any doubts, any queries, or any askings, or any other regarding other things, you can write down in the comment section. Hope you can enjoy this class, and I am requesting all of my dear students to please watch our channel and be with us, and please subscribe our channel. So till then, we will goodbye. We will meet again in our new class.